Depending upon the ease of finding the error, there are two types of errors, that is a determinate errors and indeterminate errors. Right? So determinate errors are these are errors in which can be determined. These errors can be determined. Right? So these errors can be determined and whose causes can be located and which can be rectified under suitable conditions. These have definite value and are of the same sign and magnitude. Indeterminate errors are those errors which cannot be easily determined. They do not have a definite value. Indeterminate errors arises in a measurement due to the causes over which analyst has no control. Most of the times the analyst has no control over the causes that are due to the indeterminate errors. The random or indeterminate errors in the results of an analysis can be evaluated by methods of statistics. So these errors can only be evaluated through the methods of statistics. Normally it is based on the assumption that random errors in an analysis follow a normal distribution. So we have to assume that whatever randoms error are there in analysis, they will follow the normal distribution. That means their distribution will be a normal term. So this is kind of a normal distribution and your point will be like this. So this is kind of a normal distribution. So let's see one by one source-wise classification of determinate errors. Now we're going to see what are the different determinate errors. So determinate errors are classified according to their sources. So source-wise classification we have to see. So if we see a source-wise classification of determinate errors, then we have instrumental errors, methodic errors, operational errors, and personal errors. So there are four types of determinate errors. There are four types of determinate errors, that is instrumental error, methodic error, operational error, and personal error. We are going to see one by one what is meant by instrumental error and other types of determinate errors. So instrumental errors are the errors which are caused by the imperfections in the measuring devices. So if there are devices which are being used by the analysts and if there are some imperfection in devices or instabilities in their power supply, so there can be a imperfection in measuring devices, there can be instability or instabilities in their power supply. So because of these kind of things, that is imperfection in measuring devices or instabilities in their power supplies, the errors are arised and these errors are called as instrumental errors. For example, if you are using a faulty balance, or you are using a faulty weights, so there will be always a particular error which will repeat in every measurement, and therefore these errors are called as instrumental errors because balance is an instrument. Weights are also uh, standard weights which can be wrong sometimes. Wrongly calibrated weights can lead to a problem in analysis. Then poorly calibrated glasswares and poorly calibrated instruments. These are also lead to an instrumental error. Then uncertainty in reading an instrument or a measuring system. If there is an uncertainty in reading an instrument, if uh, your instrument is showing some uncertain readings, that means these readings are not stable for a while, and that can lead to the error in a measurement. Another is attack of reagents on glasswares. This can also lead to an error. Um, Attack of reagents on porcelain, etc. This can result in introduction of foreign materials. This can lead to introduction of foreign materials in the analysis, and which can again lead to a different errors. So this is again because of the faulty or the glasswares you are using had the problem because they had attacked by these reagents. So that's why these are also called as a instrumental errors. Then there can be a drift in the electronic circuits, which can again lead to the uh, error in the measurement. And then decrease in the voltage of batteries with use. So decrease in the voltage of batteries with use. So if you are using different instruments which are working on batteries, then if the batteries have a voltage problem, which will again propagate into the measurements. So you need to make sure that you use proper batteries in the instruments so that you will get a proper readings, proper measurements. So these were some examples of instrumental errors. Now another errors, that is methodic errors. So methodic errors are errors which are inherent to the method selected. So these are errors uh, in which these are inherent to the method which is being selected for the analysis, and are most serious type of errors since they are they are likely to remain undetected. So they are um, unlikely to detected or likely to remain undetected. So most of the times these errors are not detected because these are methodic errors. These are sometimes inherent to the method which is selected. That means these are depend upon the methods which are used. Now, method-based errors are often introduced for non-ideal chemical and physical behavior of reagents. So sometimes the reagents which are being used in the measurement or analysis, they behave some unideal, non-ideal, or chemically or physically. They can be non-ideal, and that's why reactions upon which an analysis is based. So if a reagent is showing some unideal behavior, and in actual measurement or results are based upon the reaction of that chemical reagent with the analyte, that can lead to the error because that chemical itself is showing some non-ideal behavior or non-ideal chemical or physical behavior, and that's why there can be a systematic error, that is a methodic error. For example, slowness or incompleteness of chemical reactions. Sometimes reactions are slow or incomplete. Contamination of precipitate by simultaneous co-precipitation or co-precipitation or post-precipitation. So your precipitate can be contaminated because of the simultaneous precipitation of impurities or co-precipitation of the impurities or post-precipitation of the impurities. That is also a serious thing which has to be avoided. Then solubility of the precipitate. Sometimes your precipitate gets dissolved in a solvent which is being used. That also can lead to the loss of precipitate because of the washing, and that is called as a methodic error, because you're using a method which is saying you to use that particular solvent, right? Then incomplete decomposition of a precipitate or ignition. Sometimes you have to heat the precipitate in order to ignite the precipitate. In case of a gravimetric analysis, for example, in case of gravimetric analysis, if you are decomposing the precipitate but the decomposition process was incomplete, in that case what happens, the weight of the precipitate is highly influenced because of this incomplete decomposition, and which can lead to error in the final results. That's why you have to avoid the methodic errors. Then third one is operational errors. Now these operational errors are the errors which are due to the analyst, and not because of the method or procedure. So these operational errors are only because of the analyst who is performing the experiment, who is performing the analysis. The operational errors are mostly physical in nature and occur when sound analytical technique is not followed. Most of the times these operational errors are in a physical nature. So these are mostly physical in nature, and this occurs because of the inability of that analyst to follow analytical techniques, a sound analytical techniques. That means that analyst is lacking a sound analytical knowledge, sound analytical techniques. He is not able to follow because he is not aware of that, or maybe he doesn't want to do that. It can be, however, if such analytical techniques are not followed, there must be an error in the measurement. There will be definitely a serious errors in the final results. For example, mechanical loss of material in various steps of analysis. If a person is doing experiments, multiple step experiments, and if he is not able to collect all the materials in various steps, then there is a serious problem, there is a serious error in each step, and each step, if he is doing errors, then in final step there will be a huge error in the measurement. Then B, another is underwashing or overwashing of the precipitate. Sometimes analysts do not um, wash the precipitate properly, or sometimes he can overwash the precipitate. Both things are wrong. He has to perform a washing procedure exactly with the method he is following, so that a proper washing will be given to the precipitate and not under or overwashing is allowed. Then ignition of precipitate at incorrect temperature. Sometimes analysts, because of the ignorance, can ignite the precipitate at incorrect temperature, which can also lead to the result in error. Weighing of the crucible before cooling. So if you are performing a gravimetric analysis and if you are igniting the precipitate in the crucible and you are using a crucible weight, and if you are heating the crucible and if you are weighing the crucible before it gets cooled at the initial temperature at which you had weighed the empty crucible, in that case there will be a uh, definite difference, definite error in weight that you are getting at the final measurement. So you have to avoid these things. That means you have to weigh the crucible exactly at the same temperature. Blowing the last drop in the nozzle of the pipette. This mistake is done by most of the students, undergraduate students. They blow the pipette. The last drop, for example, if this is a pipette, pardon me, my drawing. For example, this is the last drop of pipette, and this is a marking, for example, and this is a 10 ml pipette. Then this 10 ml is calibrated, this pipette is calibrated by considering by excluding the last drop. So this drop is not considered in this 10 ml pipette. So that means you should not take this last drop. You should not blow. You should not blow. Should not blow the pipette, so that this drop will not come in your flask. So these things you have to avoid. So do not blow the last drop. Do not blow the last drop. Then use of reagents containing harmful impurities. If you are not using a proper standard chemicals, if you are using a contaminated impurities, then you are definitely bringing some errors in measurement. Right. Next, last is a personal errors. Last is a personal errors. Personal errors are the errors which are due to the constitutional inability of analyst. These are due to the constitutional inability of analysts to make certain observations accurately. That means if an analyte is not able to make observations accurately, for example, he is not able to recognize the difference in colors, for example, if he is not able to see proper readings, so that means he is lacking a constitutional inability, that he is having a constitutional inability. So for example, personal errors are thus the observational errors, since they occur when the analyst acts as an observer rather than operator. If the analyst is observer. For example, he is doing some titrations and he is using some indicators. In that case, he is observing the change in color. He is observing the change in color. So in this case, he is not operator, but he is a observer, because he is going to observe that change in color and he is going to note down the reading, titration reading. And thus, if he is not able to get it correct, the endpoint, if he is not getting correct endpoint, correct change in color, then he is going to make an error. So these errors which are made by this analyst are called as a personal error. These are also called as a operational errors. So personal errors arises due to some misconceptions or faulty ideas. For example, to remove a large drop of the liquid being delivered by the pipette. Some person blow the pipette or warm the bulb. Most of the students do these mistakes. So do not blow the pipette, do not warm the bulb of pipette by palm and the hand. Do not do this. So this lead to a larger volume of a liquid being transferred than it is indicated on the bulb. For example, if you have 10 ml pipette and you are blowing the last drop, then it can lead to a 10.01 ml. So this 0.01 plus minus, this is an error that you are introducing because of your lack of knowledge, your faulty idea, right? So these things you have to avoid. Then physical limitations such as color blindness is also considered as a personal error. Some people have a difficulty to understand the colors, so that is also a personal error. Then prejudice or bias. Prejudice and bias can lead definitely to an error, because the analyst himself knows some readings, he has some ideas, for example, about the results, and his tendency will be to get those results which are in his mind or in his brain, for example. So experimenter has a natural tendency to estimate scale readings in a direction that improves the precision. For example, if you are asking experimental or analysts to get uh, higher precision or greater precision, then these things are in his mind, that he wants to improve the precision, so that every replicate measurement that he is going to do will have a same value, because it is in his mind that he wants to improve the precision, and therefore he can do some errors, he can do some mistakes, right? So if an experimenter has a natural tendency to estimate scale readings in a direction that improves the precision in a set of results, or causes the results to fall closer to preconceived notion of the true value for the measurement. Sometimes analyst knows the true value, or maybe it is not true value, but he considers that that is a true value, so he tries to get the same true value, or he try to get results which can fall closer to the particular true value. So this is also very bad, because it can lead to the errors. Okay, So these were some errors. There are also different classifications like constant errors and proportionate errors that we are going to see in next video. Until then, good day, have a nice day. We will meet in next lecture in which we are going to talk about a constant error and proportionate error. So we will talk these things in next lecture. Thank you.